Okay, in this lesson we need to take a look at two different skills involving equivalent fractions. Uh, if you would like to, this would be what you would Google if you wanted to find other videos or other lessons on this on the internet. But what I'd like you to do for each of these circles here, I'd like you to shade in one of the quarters and then shade in one of the halves here. And so the problem that's being displayed at this point would be 1/4 plus 1/2. And I think you can see the dilemma here that we're trying to add two different size pieces together. Now, this is a very, very basic problem, and I think that many of you know what the answer is here, but I want to take a look at the mechanics of this. Pictorially, we can see what we're doing here, that we are trying to add two different size pieces. But a lot of times you're not going to have the picture to work with. You're going to be dealing with the fractions. And so we can see that we have different denominators here, which is the indication to you that you have different size pieces. We need to make these the same size piece. And so we can see that because 2 goes into 4, we could rewrite this 1/2 differently. So pictorially what's happening is we're going to take our picture and we're going to draw another line across here. And so we can see that when we do that, that 1/2 is the equivalent of 2/4. But I want to show you what's happening fraction-wise. When I write a denominator of 1/4, I need to ask myself, how did I get from 2 to 4? How did I break this into fourths? I took each of these halves and made it into, double the number of pieces. So I multiplied by 2 to get from 2 to 4 in my denominator. Whatever I do to my denominator, I need to do to my numerator. So 1 times 2 is 2/4. And pictorially, again, we can see and we know that 1/2 is equal to 2/4. This is the piece that I want to take a look at, because this picture here just kind of tells you gives you an example of why you would need to be able to write equivalent fractions. What we've done here is we've written an equivalent fraction for 1/2. 1/2 is equal to 2/4. And we did this by multiplying both numerator and denominator by the same number. That's what we're getting at here. And so once we've done that, we can see that this problem shifts to 1/4 plus 2/4. Now, because we have the same size pieces, we can add these numerators, and we know that our answer comes out to be 3/4. Okay, so what we've done here is we were raising to higher terms. And we did this by multiplying. So this is our skill here under equivalent fractions. And so we've got some practicing that we're going to do here. We've got another case here where we've got 3/4 and we need to rewrite it in with a denominator of 12 for whatever reason. Here we're going to have to rewrite 4/5 with the 20th into 20th. You're going to have to draw a line here. I don't think that came through. Okay, so going back to my first one here, I have to ask myself, what did I multiply 4 by to get to the 12? We know that we multiplied it by 3. I'm going to have to do that with my numerator, so 3 times 3 is 9/12. So what I'm stating here is that 9/12 is equivalent to 3/4. So here I'm asking myself, how did I get from 5 to 20? I multiplied by 4. Do the same thing here. This is where the ticket is in terms of writing equivalent ratios. So 4 times 4 is 16. Here we again need to analyze, how did we get from 3 to 24? We multiplied by 8. So this is where it might be helpful for you to go back and review that multiplication activity to be accurate with these multiplication outcomes. Here I'm analyzing that to get from 8 to 32, I multiplied by 4. So here I come up with 20. So in each of these cases, we were raising to higher terms. We did this by multiplying. A case where we would need to do this is if we were adding and we needed to find a common denominator. So this is a sub-skill for where we're going. So in each of these cases, we wrote an equivalent ratio by multiplying both numerator and denominator by the same number. Okay, in this section regarding equivalent fractions, we're going to be switching gears somewhat, but we are going to be writing equivalent fractions by reducing to lower terms, and this means that we're going to be dividing. So there's a little bit of a shift in our thinking. First of all, we're going to be given just one single fraction, but here we have to think about what number goes into both of these numbers. In other words, we are looking for a common factor, in this case, for both 10 and 12. Because both of those numbers are even numbers, we know that 2 goes into both 10 and 12. Therefore, we can divide both numerator and denominator by 2. So I'm going to write that here to kind of help us remember what we were doing. So 10 divided by 2 is 5, and 12 divided by 2 is 6. And so what we're stating here is that 10/12 is equivalent to 5/6. 5/6 is just written in simplified, reduced terms. So that's what we're going to be doing for all of these. We're going to be looking for a common factor for both the numerator and the denominator. In this case, 6 goes into both 24 and into 30, so we're going to divide both numerator and denominator by 6. And we come up with 24 divided by 6 is 4, 30 divided by 6 is 5. This next case, we're recognizing that 4 goes into both numerator and denominator, and that would leave us with 1/4. In this case, 5 goes into both numerator and denominator, so 15 divided by 5 is 3, 25 divided by 5 is 5. So you wouldn't have to write all of this, our thought process down, but I'm including it here so that you can see what it is that we're doing. This is the ticket in writing equivalent fractions when we are reducing to lower terms. You're dividing both numerator and denominator by the same factor. Okay, here we've got a little bit different approach here. We can use the same approach. We can look at 12 and 4. Both of those are multiples of 4, so 12 divided by 4 would give us 3. 4 divided by 4 would give us 1, and then we can recognize that 1 goes into 3 3 times. Another way that you could have looked at that is just said, 4 goes directly into 12 3 times, which is the other simplifying skill that we did earlier. In this case, we can divide both numerator and denominator by 8, and that would give us 1/1, which is equal to 1. So that is actually simplifying to a whole number, which can happen now and then. Okay, in this next section, we're going to be using both skills when we're simplifying. In this case, I can recognize that both 18 and 45 are multiples of 9, so I can divide both numerator and denominator by 9. So I think you can see, again, you're going to have to be pretty slick with and accurate with your multiplication facts, so you might want to review those by doing that multiple activity that we did earlier in the term. So 18 divided by 9 is 2, 45 divided by 9 is 5. In this case, we're looking at this and we're recognizing, wait a minute, this top number, our numerator, is bigger than our bottom number, our denominator, so that tells us that we've got an improper fraction. But most of us don't have our multiplication facts down for 18, and it might be easier to simplify, in other words, reduce to lower terms before we start to think about converting to a mixed number. So I'm looking at this and going, they're both even numbers. So I want to get my numbers small so I can be accurate when I'm dealing with this. So I'm going to divide both numbers by 2, and that's going to give me 19 over 9. And now that's a little smaller, and I can recognize that 9 goes into 18 2 times with 1 left over, because 2 times 9 is 18 with 1 left over. So here I had to use both simplification skills. So I want you to be aware of that. In this case, both of these are multiples of 9. So I can divide both numerator and denominator by 9. So 72 divided by 9 gives me 8. 27 divided by 9 gives me 3. And here again I can recognize that this is top heavy. It's an improper fraction. 3 goes into 8 2 full times with 2 left over. So this would involve both simplification skills to get to our final simplified answer of 2 2/3. Same thing going on down here. I can divide both numerator and denominator by 4. 48 divided by 4 is going to give me 12. 40 divided by 4 is going to give me 10. And I'm looking at that again, and I can say, gosh, I can divide both of those by 2 as well, and that would give me 6/5, which would reduce to 1 1/5. So do you see how I did 2 different reductions there before I did my conversion to a mixed number? Okay, our next one, they're both divisible by 4, and that would give me 2/9. So nothing major going on there. Here, 7 goes into 42 6 times, and I can just simplify it by converting to a whole number with nothing left over.